away. Phone's away. Pay attention.
Well, this is fun.
I don't care.
Okay.
Kenley.
Okay.
As small as that's going, that's small as that's going. Okay, 6-1. Okay, we're going to look at the inverse trig functions. And we have already used the inverse trig functions all the way through the semester. When did you use your inverse button, your inverse sine, your inverse cosine, your inverse tangent? When did you do that?
Looking for an angle.
When you were looking for an angle. We're going to explore those inverse trig functions a little bit. So an inverse, the inverse trig functions. They give back an angle when you know the ratio. Give back an angle when you know the ratio. So, examples of what we have used: inverse sine. Okay, it would be nice if they just left it at inverse sine. There's another way to say inverse sine. It's called arc sine. I don't even know the history behind that, but the book will use this, arc sine. They're identical, means the same thing. Why do we need two things to say the same thing? I don't know.
That's one class, that's why.
Maybe, I don't know. I think it's because back in the day they couldn't do these superscript things. They didn't have computers. You had the typewriter. I think it was a way to avoid that, having to get that raised up in the air. So the book will use arc sine, arc tangent. So when you see that, it's the same thing here. Now, you need a little table here. The inverse trig functions have a restricted domain. You know when we did just the regular trig functions, we went all the way around the whole circle from 0 to 360? Was our domain. With the inverse ones, they limit the domain and range. So this table you're going to need for your homework today. Here's the function. I'm going to give you the domain, not so much. So I'm not going to bother with domain because I know you don't care. We're going to leave that one blank. But the range and the quadrants on the unit circle you're going to need. Okay, so we'll do inverse sine first. The range on inverse sine. Range is what our y values are going to come out, our angles. Remember, x is the ratio. I should probably said that up here. X is the ratio, y is the angle. Do you want me to say that?
Yes.
X is the ratio, y is the angle. So the range for the inverse sine function only goes from negative pi over 2 to pi over 2. So I'm giving it to you in radians. What would that be in degrees? What's pi over 2 in degrees? Do you have your circle sheet? Can you find pi over 2 on there? Where is pi over 2 at? 90. So where is negative pi over 2 going to be?
Negative 90.
Negative 90, which is down at that 270. So the range is negative 90 to 90. Same thing. What two quadrants are we going to be looking at then if I'm going from negative 90 to positive 90? 1 and 4. We are only going to look in quadrant 1 and quadrant 4 for our angle measures for sine. I don't care about the domain. You don't care about the domain.
Then why did we even make a column for it?
Well, I just said we're going to leave it blank. It's okay. Well, it's going negative 1 to 1, but if you want it, negative 1 to 1. Okay, there you go, negative 1 to 1. Inverse cosine. Negative 1 to 1, because that's all the ratios can be. Here, the range is going to go from 0 to pi over 2. Which means 0 degrees to 90 degrees. Oh, not pi, sorry, pi. Not pi over 2. Where's pi at? How many degrees?
180.
180. So 0 to 180 for cosine. What two quadrants are we going to be looking at?
1 and 2.
1 and 2. Inverse tangent.
Can you wait for a second?
Oh, sure.
Does that say 0, pi over 2?
Just pi.
Just pi.
Just pi.
So 0
To 180.
pi.
Okay.
Stop it! So negative 1 to 1.
Tangent is negative infinity to infinity. Because remember, anything can be, because it's the two legs divided. Tangent is going negative pi over 2 to pi over 2. Which is the same thing as negative 90 to 90. I'm not going to write that down again. So what two quadrants are we going to be looking at when we're doing the inverse tangent?
1 and 4.
1 and 4 again. The reciprocal functions, do they match? No, of course not.
Why would they make it that easy?
Why would they make it that easy? Inverse cotangent, negative infinity to infinity. Here, 0 to pi. What two quadrants are we going to look at?
1 and 2.
1 and 2. And then, inverse secant. I don't care about the domain. I'm not going to write it down because it's obnoxious. 0 to pi. Which means
1 and 2.
1 and 2. You'll see how easy this is once we get this down.
No, I'm saying like you're going back. I'm getting really stressed out because I can't read that. Is that negative 1 to 1 in the domain?
Nope.
She's not going to write it down.
No, because it's obnoxious. And our last one,
So what's the,
inverse cosecant. Is going to go negative pi over 2 to pi over 2. Which means we're going to be looking in quadrants
1 and 4.
1 and 4. There's no 3, but there's a 2. 1 and 2. You're either 1 and 2 or you're 1 and 4.
3 is kind of ugly duckling.
Ugly duckling. Okay. Now,
No, just
okay, I will wait. This table you're going to need, until you memorize this, you're going to need it for just about every problem. You're going to be looking at this last column to decide what two quadrants on my circle sheet am I going to look at. All of the answers are going to be on the circle sheet. So how hard can this be, right?
I guess.
You're just going to find a spot on the circle sheet and write down an answer.
Fair enough.
This last column is telling you where to look. So keep this handy.
You might want to laminate it.
Are we ready yet?
No.
No. Are we ready yet?
No. Why you don't?
I really don't think I wrote that.
You actually did this time.
Oh.
I thought,
Gosh.
I started behind.
I'm usually like way cut
Oh.
up, but
Okay.
You gotta shake it, you gotta shake it out.
So, what you really need is just the last column.
Then why did,
You forced me to write those domains in, and I got lazy down here.
Okay, sure, you made a column for it, and then you're like, no,
I just said, oh, I'm going to leave them blank. It's okay. Because we usually going to talk range, you want to talk domain too, but we got material to cover here.
so we only need this quadrant on the unit circle, that's the only thing we need out. We should have out the domain.
Are we ready?
For what?
Have any
Okay, I didn't hear any no's. Here we go, example 1.
Do you take up a lot of space?
Nope. Find y in radians, no calculator. Because we could type the inverse sine or inverse cosine right in our calculator and get a decimal form, but we don't want to do that. We don't practice using this circle sheet business. First one. You need the circle sheet out. So don't just copy these down. Have your circle sheet out and look for these answers to make sure you can find them. So we want the inverse sine of 1/2. So we are looking for a sine, an angle that has a sine ratio of 1/2. What two quadrants should I be looking at?
1 and 4.
So look at your 1 and 4.
This is 0.
Where
30 degrees.
Where does sine equal 1/2 at?
5 over 6.
30 and 150.
Okay, and I want radians.
5 over 6.
5 or 6 and 5 or 6.
Why do you say 30 is
Look in quadrant 1.
Because we're looking for a half, and there it is.
Look for sine to equal 1/2. So you're looking at the y values.
Because it's another
What
one.
angle does that happen at?
Degrees.
I want a radian.
5 over 6. Oh, so it's just 5 over 6. So
Yeah.
okay,
Yeah.
I just need to know.
Wait, but you don't use like 150 is 1/2 too.
It should be negative 1/2. 150 is in which quadrant? Where do we look for inverse sine? Only quadrants 1 and 4. That's why you need this. You're only looking in the 2 quadrants.
Doesn't mean make it again.
Are we good? Everybody good?
Yeah.
Haley, you good? Okay, just checking. Good. Same problem. Y equals arctangent. That just means inverse tangent of negative square root of 3. So this is inverse tangent. What 2 quadrants should you be looking in?
1 and 4.
And
And 3.
5 pi over
No, 4.
3.
So inverse tangent, 1 and 4 only. I want a negative, so it's probably in 4. Where does tangent
5 pi over 3. 5 pi over 3.
5 pi over 3? Now, I like 5 pi over 3.
Me too.
Let's keep it.
I know, but the domain said that the angle had to be between negative pi over 2 and pi over 2.
That's the range, right?
The range, I meant range, yep, I meant to say range. I need, because it's in quadrant 4, I need a negative angle measure. So what would that 5 pi over 3 be equivalent to in terms of a negative angle?
Negative 5 over 3.
How'd you get negative pi over 3?
I just looked at it.
Wait. No.
I think I might need a circle sheet to show you this.
Pi over 3? Do you go the opposite way?
Yes. How much, let me see your circle sheet, Matt, so I can show them what happened there. Okay. Everybody had no problems finding this 5 pi over 3, correct?
Yeah.
Correct.
I just need to know, well, I can't have, if I'm down here, I got to have a negative angle measure. I need to know what this is in a negative direction, how much this is.
Oh.
Well, if I just look at the top, that's equivalent to pi over 3, so it's just negative pi over 3. So negative pi over 3 is what we wanted.
Why did you want negative pi over 3?
Because the range, if I'm in, I have to go between negative pi over 2, so I want negative pi over 2 is down here, which is equivalent to positive 3 pi over 2.
Wait, where's negative pi over 2?
Just going backwards, pi over 2. You don't have any negative angle measures on here.
What are you doing?
Okay.
Why are you?
Let's write it. If you don't get it, write them in. What would this be in terms of a negative angle? How much did I go?
Negative 30?
-30. So that would be equivalent to negative pi over 6. So this 11 pi over 6 is equal to negative pi over 6.
Okay.
So if you want to write that down here, you can. Negative pi over 6.
No, I got that, but why are you saying, why do you want us to write it negative pi over 3 as opposed to 5 pi over 3?
Because 5 pi over 3 is not in between these two numbers. But negative pi over, if we had degrees here, it would make more sense, but
So why did we ever write in the other, why did we just write in negative pi over 6 instead of, why did we put 11 pi over 6?
I don't have the answer to that.
So the answer is negative pi over.
Correct. The correct answer is negative. Is 5 pi over 3 technically wrong? No.
Well, isn't 5 pi over 3 between negative
Nope.
pi over?
Not numerically, no. It is not.
Where is pi over 2 and negative pi over 2? Maybe that's 90 and 270?
Yep.
So how is it not between 90 and 270?
Because it's going around this way. That's how I get to 5 pi over 3. And according to my thing, I can only back up this much and go forward this much. That's all I can do, according to my range. 5 pi over 3 has to spin all the way around, so I've gone beyond my little window. Let's just say if you're in quadrant 4, you got to convert it to a negative. Okay?
Okay.
Okay, moving on. Y equals inverse cosecant of negative 2 square root of 3 over 3. Okay, we are. Let's convert this to something we know. Let's flip it over. If I flip it over, what have I converted it to? An inverse sine. So I'm going to flip this over so that it's something I can look up. I'll have negative 3 over 2 square root of 3. Well, I'm not going to find that on there because it's not in a nice form. So if we hit it with a 1, yep.
Why?
But they're not on your sheet. We've only got sine, cosine, and tangent on your sheet.
Oh, okay.
So, what does this turn into?
Negative square root of 3 over 2.
Yeah, that.
Oh, it's,
Well, before I simplify it,
yeah.
now I can reduce.
Negative
So,
1/2.
negative square root of 3 over 2. Okay. So, look on your circle sheet. I'm doing an inverse sine. Sine is only quadrants 1 and 4. If it's negative, that means it's in 4. What's the positive angle measure there? Quadrant 4, the positive
300. Oh, I thought you
as a
were
radian.
negative.
Oh,
As a radian, 5 pi over 3.
5 pi over 3, so what's my correct answer going to be?
Negative pi over 3.
Negative pi over 3.
Wait, what in?
I'm not getting the jump from 5 pi over 3.
Sine, okay.
Where'd you,
It's the one we just did. If you got B, why aren't you getting C?
I don't know.
okay, I got 5 pi over 3, because that's 300. Now why
Yep.
are you jumping to negative pi over 3?
Because I can't have that positive angle in quadrant 4.
Oh, okay.
I need what it is as a negative. What it's equivalent
Oh.
to as a negative.
Okay, gotcha.
Okay, whew.
Alright.
Maybe I should have done this one first in the degrees. Maybe that would have made more sense. Find theta in degrees this time.
How many examples are we doing?
Till you get it. No calc. Theta will equal the inverse secant of 2.
still the direction.
Nope, it's the problem. A. I only did one of these.
Okay.
I can do another one though if you want.
Okay. No, it's okay.
Okay.
Okay,
Let's-
so it's gonna be in quadrant 1 and...
Let's switch it first.
Yeah. Kelly, you're jumping ahead. Sorry.
Let's flip it over. If I flip it over, what function will I have?
Cosine.
Inverse cosine of 1/2. Cosine, you're looking in which two quadrants?
1 and 2.
1 and 2. So cosine's going to be positive in 1.
Pi over 3.
I want a degree now.
Wait, how come you...
60 degrees.
60. Short.
Yes?
How come you wanted to change it to cosine?
Because on your circle sheet, you only have sine, cosine, and tangent visible to you.
Oh.
You'd have to physically flip all those over. I think it's easier just to do this.
Okay.
So why'd we put the cotangent and the cosecant in the paper?
Because we can? I don't know. So you see all of them? We're not going to use them, but it's okay.
So would 60 degrees just be...
You forced me to write that domain down when you didn't need it. Jeez, you guys.
There's a column for it.
Ah. Okay.
Oh my god, I should
Yes.
talk about this one more time.
Okay, so it's 60 degrees,
Mm-hmm.
but it's okay to put that, right?
Yep.
It's in between 0 and 180?
Yes.
Alright.
So we don't have to worry about any negative stuff when we're using quadrants 1 and 2. Just the quadrants 1 and 4.
Negative one.
Okay, let's do a negative one. Let's go arctan
No, she's not reading. Who?
of
We'll talk about this at lunch.
negative square root of 3 over 3. Oh, tangent. Oh, sorry, I picked the wrong one.
Yeah.
Oh, no, that'll work. That'll work. That'll be good. Let's look at negative. So what two quadrants are we looking at?
1 and 4.
1 and 4.
1 and 4.
So it's
Negative
330.
So it's 330 as a positive.
So then it's negative 30.
Negative 30 is what we want to write down. I should have started with the degree one. That might have made more sense.
Yeah, radians.
Yeah, radians. We don't have any concept of those fractions. Take a look on your circle sheet. Make sure you understand where all that came from.
Okay, and we'll talk about this. Why are you subtracting 30? Where?
I'm not. I'm saying it equals a negative 30 degrees.
Okay, alright, follow.
Okay?
Alright, and go. Yes.
The negative is the answer. Quadrant 4, you got to give me a negative angle measure.
Quadrant 4, negative angle measure of 330 degrees.
Okay. No.
Of course not.
Is it basically just this stuff?
It's just using your circle sheet today. Oh, and I'm going to give you a calculator one right here.
So this is basically all we're doing today?
This is it. You're making it difficult on me. Okay.
You guys are both like,
I'm actually gonna do this this time,
Good.
because I
We should have
understand
get a
it.
calculator.
This is easier than other stuff.
Levi.
Why do you say it just like that?
With the calculator this time.
Me too. Why me?
Arc cosine of 0.7152. What's nice here is the calculator will put the negative in. It will give you the negative angle if it's in that quadrant 4 or if it's in quadrant 2. You don't have to think about it.
Would be radians.
Well, I don't know. If I want a degree answer, should you be in radian mode?
No.
Hmm.
I'm just saying, 'cause
Oh.
it's inspiring shot.
I'm just going to answer that question with a question. Oh, zing! Call that a zinger. At least you were aware of your mode. That's a good thing.
Well, I just
I'll give you
think
I'll give you
it's
bonus
that
points there.
radian right there.
So 44.3.
Is that like point blah blah degrees?
Nope, that's a ratio. That is the adjacent divided by the hypotenuse. That's what it's coming out.
Doing sig here.
Do we have to do
I don't even care.
Like opposite cosine.
Inverse cosine.
Inverse.
0.7152. Enter.
should we just do 44.3?
No.
Inverse.
No, I was trying to go.
Any problems typing that in? You need to be in degree mode, because I want a degree answer. And it says, I don't know.
Yeah, this is.
I really like this stuff.
Yeah, this is-
Okay.
The rest of the year. How did this happen?
Inverse cosecant,
This looks better. Stay close, Deacon.
yep, of 2.513.
Type in to get 44.3.
Honest to God, inverse cosine of 0.7152.
Okay. Okay, I got it.
Okay,
See, it's stressing me out, it's not me. Why, I got it.
okay.
On the second, we just.
We don't have an inverse cosecant button, so what are we going to do with this?
Flip it
over.
Flip it over and rewrite it, and then use your inverse button. So how do I flip that over? 1 over 2.513. So you just type in, start with inverse sine, and then 1 divided by, and it will give you the correct answer.
They were like-
6.6. Wow, of course I always say numbers.
I've got the devil problem that showed up.
That always happens to me. I got 23.4. Yeah, I got
Oh.
23. I probably did
Of
it
course.
wrong. Yeah, she did it wrong.
23.4.
Of course, it's the double numbers. Why? How did I do that wrong?
That's not you.
Okay, last one.
That was cool. 66.6.
Inverse tan of negative 1.25. So if we were doing circle sheet, we'd be looking in quadrant 4, and we'd have to convert to the negative angle. But watch what the calculator does.
Uh-oh. Yeah, let's see. Watch it give it an error.
It won't.
Negative.
The programmer's built in that domain for the angle, so when it's in the 4th quadrant, it's coming up with the negative value. You don't even have to think about it.
Good for them.
Yes. Thank you, programmers. Did you get negative 51?
0.34.
Yep. Okay.
Think harder, not smarter.
Work smarter, not harder.
All right, now we're going to switch gears. We got one last thing to do.
Oh my Lanza.
Here we go.
Is it like about as big as the last two?
Well, there's 4 parts here. I got 4 examples, so you can go a little bit longer than that. No calculator.
I didn't mean it like that. I didn't mean it like that.
Okay, this is not cool.
Okay.
Wait,
Yeah.
chill.
This is not going to be, you're going to say, oh, all right, we've done all this before. This is not that difficult.
I feel like, can I push it into this
So it's just
One of 'em.
ugly.
One
Yeah.
of them?
Yeah.
Okay, I get it. Never mind.
Okay, no calculator. It would be easy if it was a calculator problem. We just type inverse tan, then we do sine. Got our decimal answer, yes.
ready, yeah.
Very easy calculator problem. No calculator puts a whole nother spin on it.
Oh.
Okay. You could try to look on your circle sheet and find where tangent equals 3/2.
It doesn't.
It doesn't on the circle sheet. It's not one of those nice angles. So, what you need to do is sketch a triangle. Okay?
I would use a calculator.
Yeah. So, which quadrant would this positive 3/2 be in for tangent? Considering I can only use 1 and 4 for tangent. So it's got to be in 1. So we will sketch a triangle in 1.
This really killed my day.
Tangent is 3/2. So we can find the hypotenuse.
1.
That's going to be 9 plus 4, square root of 13.
Why do you just look at me like a fly brow?
1? Where do you get 1 from?
Yeah, tell me, how did you get 1?
Well, because I figured 1, 2.
Okay, so I've got this angle here. I don't even care what the angle is. I'm looking for the sine ratio of that angle. Do you know what the sine ratio of that angle is?
Yeah.
What is it?
Oh.
Okay, 4.
3 over. You gotta hit it with a 1.
What?
2, 3, triangle.
Okay, you need to not talk for a little bit. We've got the triangle. You good with that? Pythagorean tangent, opposite over adjacent. Standing here, opposite over adjacent. And then I did Pythagorean theorem in my head. 3 squared is 9, 2 squared is 4, okay. Now all I'm looking for, and the whole problem was the sine ratio. So if I stand here, can you give me the sine ratio? Opposite or hypotenuse? And that's almost done. What do I got to do with it? Hit it with a 1.
Okay.
So would that be the answer?
That's your answer. Okay. Tangent of the inverse cosine of negative 5/13. Oh, inverse cosine. So my goal is to end up with a tangent ratio. But I need to know where this angle's at. And I know something about the cosine of it.
Negative 6 quadrant 2.
So think about inverse cosine. Which quadrant is the inverse cosine going to be negative in that I can use? 2. So we're going to sketch a triangle in 2.
Quick question.
Yep.
Like, did you just sketch triangle?
Right triangle.
Yeah, I mean, right.
Mhm.
So, and it doesn't matter.
Doesn't matter. Okay, I know that the cosine ratio of this angle is negative 5/13.
13.
So the 5 is the negative. 13's the hypotenuse. Not that I can do that one
I
in my
got this for you.
All right.
It's,
12 is it.
Exactly 12?
it's 12.
Okay.
Good job, Ken.
Okay. I want the tangent. What's the tangent going to be? Negative 12/5. Opposite over adjacent.
That's not that bad.
Wait, how come you only have to find the tangent?
That's what the problem asked for. The tangent of this angle. No, it's of.
You gotta find that, and then you gotta find that.
Yes. This helps you sketch the triangle, then you can find the ratio you're looking for.
Little house.
Okay, cosine of the inverse cosine of a negative 1/2. Actually, I'm going to make it negative 1/3. Negative 1/3.
Negative 1/3?
Would it be negative 1/3?
Yeah,
Oh, you're seeing something.
I am.
Okay.
Is that a 3?
Yeah. Let's just go through it and see. She says the answer is going to be negative 1/3.
I look at that.
Okay. What quadrant would I sketch my triangle in for this?
Negative
2.
Quadrant 2. Negative 1/3. Or that missing leg would be
2.
No. Not all
2
it's
square root
only
of 2.
3, 4, 5. That's the only one that works.
Oh, really?
3, 4, 5.
Oh, is that what she's doing?
That's what I thought. That's why I thought there was like a rule.
It's the only one that's consecutive that way.
9, 10, 11.
3, 4, 5 is the only consecutive one. Okay. I want the cosine of that. What's the cosine going to be?
Negative 1/3.
Oh. Do we really need to sketch the triangle on this one?
No.
When you've got the cosine and the inverse cosine, they kind of just cancel each other out and you get that.
Well, of course, we told you the answer.
Oh, well, I was just making sure everybody else got it.
Wait, quick question, how are you
Yep.
figuring out which quadrant it is? Because I know it's between 2, but...
You get 1 or 2, cosine's positive in 1, negative in 2. Okay. Last one. Cosine, inverse cosine of the cosine of 5 pi over 4.
5 pi over 4.
Oh, you are so good, Austin. Anytime, even though they're in the reverse order here, they cancel each other out.
Done.
Okay.
That was.
Thank God that was painful today.
For one half.
Wow. What was supposed to be easy, boy, pushed me over the edge today.
Yeah, because you were like, it's gonna be easy.
Well, it was.
Yeah, it was. No, but like, they're just saying, like, oh, she's pretty.
Lexi, I think, is what made me stressed.
And then they were stressing, so.
Well, just making that angle negative in the 4th quadrant just kind of blew your minds, I think, a little bit there. And, wow, why do I gotta do that? Ah.